follow that last part? If the voltmeter was hooked up like this, you see how it reads 5 volts? No. So the voltmeter is infinite resistance, right? Nothing, it's not going to affect the circuit. It's just reading the voltage on each side of that 2 ohm resistor. So pick a starting point. I like to start at the bottom of my battery, call that 0 volts. You go up through the battery, you have to be at 10 volts at the other side, right? And nothing, you don't hit anything that's going to change that all the way. This is just a perfect conductor all the way around to here. Now we're going to drop. We're going with the current through a resistor. So we're going to drop. We're at 10 volts on the right side of that resistor. What are we on the left side? Well, V equals IR for a resistor. The voltage across that resistor is the current times the R. So the current was, what did we say it was? 2.5. Current was 2.5 amps. Multiplied by 2 ohms gives you 5 volts. So this resistor has to have 5 volts between the left side and the right side. So if this is 10, this has to be at 5. 10 minus 5 is 5. And we come along here and we do the same thing here. 2 times 2.5 is 5 volt drop going from the right side to the left side. So we get back to 0, and that's good. You want to get back to where you started if you go around a whole loop, right? You have to get back to the same potential. So if the voltmeter is hooked up one side to 5, one side to 10, it's going to read a difference of 5. It always measures one side with respect to the other side. That's why we don't usually say, you know, a potential. It doesn't mean anything. What means something is the delta V, right? The change in potential going from one place to another. So it needs a reference. That voltmeter needs a reference. So it's measuring the voltage here with respect to there. It thinks this is 0, basically. So it's going to measure a 5 volt difference between the 2 leads. Should we see what the FET simulation shows? So this is, we have to close this switch, right? So the current jumps to 2.5. Nothing is going through these 2 resistors. They are shorted out. Everything takes the path of 0 resistance. And our voltmeter reading goes up because the current doubled, so the reading doubles there. It's just reading the voltage across that one resistor. Okay? Now we're going to close the other switch. I'll ask you the easy question first. What happens to our voltage reading when we close S1? Zero. Why is it 0? Yeah, the 2 leads are now tied together, right? You're measuring, I just told you, we're measuring that's how this thing works. It measures the voltage at one side with respect to the other side, and we are connecting them with a 0 resistance path, right? We're making them the same potential by connecting them with a conductor. That conductor has to be the same potential everywhere. So we've tied the 2 ends together. We better get 0. They're both connected to the same thing. So the delta V has to be 0 if they're both connected to the same thing. So when we close S1, when we close S1, V must be 0 because the 2 ends are now tied together. But the current can go through this other resistor now. When we close S1, the current can go through both of those resistors. We have 2 resistors in parallel, so the circuit looks something like this. Right? So these two are in parallel. So what's our equivalent resistor? Seven. You see that? These two are each 2, right? So if you have them in parallel, they act like a 1 ohm. The resistance goes in half. So the R equivalent here is 1 ohm. And this is 2 plus 2 plus 2 plus 1 is 7. And so what's our current? What do we get? 1.4-ish? So now we're closing this one. (1.43 amps), the voltage goes to 0. And if we close the other one,